Hello, welcome everyone. We're going to see the thermodynamic processes. What are the different thermodynamic processes are there? So already I've discussed about the thermodynamic system in short and the laws of gas laws and the open system closed system. But before proceeding, I would like to tell you that thermodynamic process is nothing but first of all, thermodynamic system we need to understand. If I consider some IC engine or else something fridge or else wherever there is a heat exchange it is taking place or a heat related some process is taking place, then we can call that as a thermodynamic system. So if I consider this as a refrigerator, then I can call it as a thermodynamic system. I can call it as. So here inside this thermodynamic processes will be taking place. Uh, so what type of the system it is there? Uh, there are three types of the systems that I have told in the previous video: the closed system, open system, and isolated system. If you have not watched that video, please go through that video. I have given the link in the description. So here, whatever the thermodynamic processes are taking place, uh, or else into the thermodynamic system, whatever the process is taking place, so those processes are under the control, then only the finite results can be achieved. Certain if I say when I increase the as per the laws, Boyle's law, Charles law, and Gay-Lussac's law, uh, whenever pressure and temperature are you can say directly proportional, or else pressure and volume are inversely proportional. Inversely, I mean pressure is inversely proportional to the volume. Okay, then here whenever I increase the pressure, volume will be decreasing, and volume whenever I increase the pressure will be decreasing. So these effects can be utilized in the processes. Mm, so that's why the thermodynamic process is a change in the state of the system due to the variation in the pressure, volume, and temperature during the process. The system moves from the equilibrium, from one equilibrium to the another. Okay, so that's why we need to study the different processes. What are the thermodynamic processes? So here, different three, six types of processes are available as per the standard process which have been derived. Uh, Isocoric process is there, isobaric process is there, isothermal process is there, adiabatic process is there, polytropic process, and throttling process. So these are the six processes. So these processes are related to the laws only, gas laws only. On that only we have derived. We can identify by using this process. We can identify the work done, heat transfer, enthalpy, entropy, such whatever the equations are there. We can derive from these processes. So here, constant volume process. So in this video, we're going to discuss about the different processes, and then later the derivation, whatever are there, we will discuss in the next videos. Okay, one by one, because these are the lengthy processes. So here, isocoric process means where volume will be kept constant. If I consider thermodynamic process, okay, here if I consider thermodynamic process, if I draw the graph of the pressure and volume, so if I keep a volume here and a pressure here, if I draw the pressure and volume graph, then isocoric process volume will remain the constant because volume will not going to change. So if I consider here V1, then V1 is equal to V2. Volume will remain same. So it will not going to, but only pressure will be increasing. So pressure will move from P1, P2 like this. It will going to move. So here, so that's why pressure only if it is increasing, the graph will become like this. Okay, graph will become like this. So now we are only discussing about the graphs. Then if I draw same for the temperature and pressure. If I take the pressure and the temperature here, so here as I as the pressure increases, temperature will also increases. As the pressure decreases, temperature will also decrease, because these are having the direct relations in this both. So here both are changing, because volume is only constant in the first process, isochoric process. So that's why it will be like this. If pressure increases, the temperature will increase. So from it will be initial stage P1 to P2, that is also T1 and T2, it will reach out. So here you can see, as the equation is P1 by T1, P2 by T2, because volume is constant, because the volume is constant. Then the next, here you can see this one, the graph is PV graph is like this. Then in isobaric process means the pressure is constant. So here bar, usually bar we are using the notation for the pressure, then on that you can remember it. So it is related to the pressure. So here pressure is constant, then graph will be like this. So if I draw pressure and volume graph, volume will remain same, P1 and P2 will be same, equal. Here I can take, so P1 will be equal to P2. Pressure will not going to change, but volume will change from V1 to V2. So that's why the graph will be like this. And if I draw the temperature and the pressure graph, so here pressure again remains constant, though it will be also similar one. Then in the uh, so here the same graph has been drawn. Then next comes the isothermal process. Isothermal process, the temperature remains constant. So if I draw the pressure and volume graph, so initially V1 and V2 will be there, pressure will be P1 and P2 will be there. But pressure and volume are having inverse relations. Pressure is inversely proportional to the volume. So that's why it will be graph will be like this. Because as the pressure decreases, volume increases, and as volume increases, pressure will be decreases. Or else if you are doing vice versa, volume if it is decreasing and the pressure will be increasing, you can call this one as same. If the volume is decreasing, then only pressure will be increasing. So it will be like this. And if I draw the pressure and the temperature, so it will be like this, because the temperature will be constant, so that's why the graph will be like this. Then next, adiabatic process. In the adiabatic process, no heat transfer occurs between the system and the surrounding. Heat, whatever it is there, it will be constant. So here the equation, that is a PV raised to gamma is used. So gamma is nothing but Cp by Cv it is. So next, in the polytropic process, the polytropic constant is given, that is PV raised to N. It is given. It is constant. So here N is nothing but polytropic index. So in the next video, I will discuss in detail. So you can go through that one. Just I am here discussing about the highlights. In the throttling process, the process occurs when fluid passes through the restricted restrictions, such as a wall or a plug. So what happens here, because of that one, pressure decreases suddenly, no work interaction, no heat transfer, enthalpy remains constant. H1 remains equal to H2. So whenever I take on a certain uh, small orifice and all, so when the mass flows through this one, here there will be a choke point. So this is the throat, and that's why it is called as a throttling process. Throttling process. Okay, then suddenly expansion will occur. So because of this, what happens? There will be no exchange of heat, no work interaction. Suddenly pressure will be decreasing. So at that time enthalpy will be remaining constant. H1 is equal to H2. Then so this process is used where in the refrigerator, air condition, and gas liquefaction process. That's why it's used. And then combined process is there. Combined process we will going to discuss, because here we are utilizing in combination with the constant volume as well as constant thermodynamic process and isobaric process. When we mix up these processes, then we can call them as a combined process. What are those different combined process? Otto cycle is there, Rankine cycle is there. So different cycles are there available. So here, where these process are used, because here adiabatic process, in adiabatic process used in the compression in the diesel engines it is used, compression in steam turbine it is used, adiabatic process. Then isothermal process is used during the slow compression expansion of the gas. Gas is in the cylinder and surrounding at a constant temperature water. At that time it is used. So heating of water in an open vessel, we can call it as a isobaric process. Then expansion of gas under the atmospheric pressure, we can call it as a isobaric process. So these process whatever are there, we are using this process in the day to day life, because the whatever you are you are utilizing a pressure cooker or else IC engines, your truck, tractor. If you are if you are using the balloons for the decorations and all, there also whatever the process it is occurring, it is occurring because of this some thermodynamic process only. So that's why these thermodynamic process whatever are there different, those are important. So in the next video we will going to see the derivations and all whatever related to these processes.